So now let's look at our last container for this week, the tuple. Tuple is another container, and we can put it alongside the set and the list, although it is pretty basic what a tuple is. And we don't use a tuple that often, although we're asked to use them from time to time, and you're free to use them at any time. A tuple is just like a list. As you can see, ordered, non-unique, and sequence. It's an ordered non-unique sequence, but it's read-only. So a tuple is almost identical to a list. And actually, if we were to just change the braces, we would suddenly have a tuple. Before we used curly braces to have a set. Now we're using parentheses to have a tuple. Now I've got a couple of duplicate values in here, and I just wanted to show you that if I run this, I'll see that the values are maintained. The order is maintained and the duplicates are maintained, and that's because of the nature of a tuple. It's ordered, non-unique, and it's a sequence. What makes it different from a list is that it's read-only. Read-only means it can't be changed. There's no appending to this tuple. There'll be no extending it. You could add two tuples together and create a new tuple that way, same way you could with an integer or a list. But you can't add to a tuple. We know that a list is an expanding accordion of values, and as you add values, the list expands to accommodate those values. But with a tuple, that's not the case. However, because a tuple is an ordered, non-unique sequence of values, there are a lot of things that we can do with tuples that we were able to do with lists and sets. And among those are the things that are really available for any of the containers, and that is looping. So if I run this code, I should see first the sum of all those values. It's kind of hard to tell. Oh, wait, I better get an exit in here. Let's run that again. So what am I doing with this tuple? I'm summing up the values, I am looping through the values, and I am getting some information about the values based on, based on the various operations. So the sum of all these values, 20.7 looks like. The length of the tuple, 7. The maximum value within that tuple is 3.9, the minimum 2.1. If I want to sort the values, I'll find that all the values are still there. The duplicates are still there. What we get back is a sorted list of those values. And then if I wish, I could loop through the values using for. So all of the things that we've seen work with the other containers work with a tuple, including the ordered sort of operations. For example, printing the first item or the last item, or getting a slice. Let's say I will get 3 to 5. 3 to 5 on this tuple should get me 0, 1, 2, 3, 4, and 5. I should see that represented if I print it. So now I'm seeing the first item, 3.9. I'm seeing the last item, 2.1. And I'm seeing a slice of items from 3 to 5. Oh, look, I made a mistake myself. 0, 1, 2, 3, 4, and not 5. Right. So that's why I'm seeing 2.3 and 2.9 for that slice. A tuple with 2.3 and 2.9. That is third, fourth, and not fifth item in tuple. So that's how a tuple works. It works just like a list, except it can't be changed. And that's really all you need to think about when you're thinking about a tuple. One other thing, though, that I might mention about initializing a tuple is that if we create a series of values and we don't give it any braces, as we're doing in Z, we're going to find that we've created a tuple. So usually when we notate a tuple, when we're initializing a tuple, we do give it parentheses to indicate that it is one. But if we should ever have 3 items that are not bound by parentheses, brackets, etc., it defaults to a tuple. And that, again, is a read-only list. It's not a list, it's a tuple object, but it's like a list in that you can do everything you can do with it as you can with a list except for change it.